set 1, 2, 3, ... What's that called? And the hint, I guess, kind of, it starts with an N. Yes, natural numbers, N, are all counting numbers. So you know when you're like little, you start counting on your fingers? That was the first number system as a little kid that you learned was the counting numbers, natural numbers. Okay, so the next one is whole numbers. W are all positive integers and 0. So that would be all the counting numbers and 0. Okay, so now if I add all the whole numbers and their opposites, what would that be called? And it doesn't start with a Z. Integers, yeah. Integers. And you might say, where does a Z come from? A lot of these things aren't necessarily the abbreviation of an English word, right? Because math is pretty universal. Okay. So, do you remember from grade 9, what are the number systems that are written as a fraction? Rational numbers. Yeah. Rational numbers are Q. Are any numbers written in the form of a ratio? That's where the word comes from. Where A and B are integers. And B cannot equal 0. Why can B not equal 0? Because then why won't it work? Yeah, you can't divide by 0, right? And B is considered the denominator here, so that's why B can't be 0. Okay, and then what would be the other number system that includes not rationals? That's irrational. Irrational numbers. And that's got a Q with a bar on it, which means not, literally, not rationals, are any number that cannot be written in the form A over B, where A and B are integers and B cannot equal 0. So now, what number system comprises the rational and irrational numbers? I'm sorry? Yes. Real numbers, and that is R, are the union of the rational number set and the irrational number set. So here is kind of a Venn diagram of all the stuff we just talked about. And the way this works, of course, natural numbers are starting 1, 2, 3, 4, yada, yada. Then the whole numbers adds on a 0. Then the integers add on the opposites, right? And then the rational numbers add on the fractions and the decimals. And then we have the irrationals here, which are the non-repeating, non-terminating decimals. And that comprises of the real number system. So your calculator is a real number system. Yes? Can anybody tell me what another number system is that isn't the real number system? It's not the fake number system. Yeah? No? I'm sorry? Imagine. So I know a lot of people say it's the imaginary number system. You're close. The imaginaries are part of it. It's actually called the complex number system. So the complex number system consists of the real and the imaginary part. So imaginary would be totally out. And can you give me an example of an imaginary number? You've heard of it but don't know an example. No. Actually, infinity isn't a number, so I need a number that's imaginary. No, pi would be irrational. The square root of what? 7. That would be irrational. You're close with the square roots. No. The square root of, say, -2 or something like that. Of something you can't do, right? And actually, in one of the AP topics, we actually talk about imaginary numbers. It's exciting. Okay, so we're going to go over which number system best describes these numbers. So, of course, some of these belong to a lot of the systems, but which one is the best description of it? So, what would be the best description?
Natural.
Yeah, natural. Okay, what about 0.25? Rational, very good. And remember the definition of rational was it can be written in the form a over b. Of course, any terminating decimal can be written as a fraction. Pretty easy. It's you know, the way you read it is this is, instead of saying 0.25, what's the real way you're supposed to say this? Huh? You could say 1/4, but how would you actually say this number? Yeah? Yes, 25/100, which of course reduces to 1/4. So you're saying 1/4, right? But I guess where I was going with this, any number that is a terminating, it's pretty easy to see how it would be considered rational. Okay, square root of 35, what would that be? Irrational. If you actually were to evaluate the square root of 35, you would get a number that has no repeating nature and it doesn't end, right? Okay, what about -5? Integer. Very good. Pi? Irrational. So these should be some easy points on a test, right? Like just kind of trying to figure out what these numbers are. Okay, so what about 0.131313 ... So that means it goes on forever. And because it's establishing a pattern of, you would know what the next number would be, right? So what would this be called? I'm sorry? Rational, yeah. Okay. Does anybody think they know what fraction that is? 0.13 repeating? 1/6. 1/6 is 0.16 repeating. Close. We'll go back to that. You can think about that. How about, I'm sorry? Okay. How about G? Well, what is the square root of 25? 5. So what's 5 the best description? Natural, yeah. Okay, what about 0? Whole. 0.123456789. Yeah, there isn't really, although you might think because it's going up by digits, that's not considered a pattern per se, and it's going on forever. What about 3/4? Rational. Okay. It says, write each number in decimal form, round to 2 decimal places. Some may already be written in decimal form. Place the above numbers on a horizontal number line below and clearly label the number line, use an appropriate scale. So here's our number line right here. Okay, so basically if I were to say I want you to order these numbers, you need to have them in equivalent form, meaning they can't all be in square root form, they can't all be in fraction form, or they can't all be in decimal form. But what's the easiest thing to actually convert them all to? Decimal, right? And I think if you were to ask most students, they like decimal form rather than fraction. The problem with fraction form, of course, is you have to have a common denominator in order to compare, right? And then the other problem with, say, square roots is, although you can evaluate, say, the square root of 16, square root of 45, maybe not so much, right? But the other lesson we learned how to do this. Okay, so 3 is already in decimal form. Did you know that? Yeah. You might say, well, it's in whole number, but really it's in decimal form. Same with B. What about C? It's saying to round to 2 decimal places. Well, we're gonna put root 45 approximate. I don't know why it says 2 decimal places. 6 point what? 6.8. Okay, so around 6.8. Pi is approximately 3.14. This is already in decimal form. This is equal to 4. Yes, this is already in decimal form. What's 3/4 as a decimal? 0.75. So it's saying you have to have an appropriate scale. So probably the best scale would be the whole numbers. Actually, is there anything negative? Oh, yeah, there is negative. So we need to have an integer scale. So I'm going to put 0 in the middle. And then I'm going to go 1, 2, 3, 4, -1, -2, -3, -4. Oh, yeah, shoot. You know what? I know you can't do this, but I can. Oh, I thought I can. I'm going to shift this a little bit. I wasn't thinking about that very good. Hold on. I'm going to move this over. I'm trying to move this over, but for some reason it's not. There I go. Just to give myself enough room. Okay. So 5, 6. I'm still going to run out of room. 7. Anyways, I'm going to use a different color pen. So 3 is pretty easy. So that would be right here. I'll put A there. Okay, so I'll give you a moment to place them on the number line, okay? You can do it with the letter there. Okay, so B is 1.41. I don't think I have another 1 point whatever, so I'm going to... So there's my B. My C is 6.8, so there's my C. My D is -3. My E is 3.14. So say right about there, there's my E. And then 0.17 is, say, 0.17 is right there. So that would be F. G is 4. H is 0. I is 0.5. And 0.75. What the heck? I put that in the wrong spot. Try that again. 0.5. There we go. And then 0.75 would be J. Yes? Is that what you got? Okay. So it says, note, radicals that are square roots of perfect square, cube roots, perfect cubes, so on, are rational. Rational numbers have decimal representations that either terminates or repeats. When an irrational number is written as a radical, the radical is an approximate. Yesterday or Friday's class we went over exact versus approximate value of the irrational number. We can use square roots and cube root keys on the calculator to determine approximate values of irrational numbers. Okay.